In this video, we are going to be doing some piecewise functions, which we've already done, but we're now going to incorporate what we've learned about graphing quadratics. So in this first one, remember, these are two different two different functions. Some of ours are going to be lines, some of them are going to be quadratics. And then remember, this is the domain restriction. So for example, this first one is just y equals 2x minus 1. So it has a y-intercept of -1. Oh, sorry, we're not asked to graph this one. I'm getting ahead of myself. This one we are just asked to evaluate. So here we want to evaluate what is f of -2. So first I have to decide which piece does that fall into. So -2 is less than or equal to 1. So that means I'm going to use this first equation. So I'm going to do 2 times -2 minus 1. Okay, so I get -4 minus 1, which is -5. F of 3, so this time 3 is not less than or equal to 1. Instead, 3 is greater than 1. So since it fits this restriction, we're going to plug it into that second piece. So we're going to do 3 squared minus 2 times 3 plus 1. So I get 9 minus 6 plus 1. So I get 3 plus 1, which is 4. Okay, now we're going to graph one. Okay, so remember, these are two different pieces, right? So that first one is y equals 2. The second one is y equals x minus 2 quantity squared. Okay, so y equals 2 is just a horizontal line through 2, right? So this is what that would look like. But it only looks like that when x is less than 1. So where x is 1, I'm just going to draw a kind of dotted line through there. X equals 1 right here. So it follows the y equals 2 piece everywhere that x is less than 1. So that means it's going to look like that to the left, and I'm going to get rid of the right side. And since it's just less than, not less than or equal to, I'm going to put an open circle right where x equals 1. So it doesn't include when x is 1, only when x is less than 1. Okay, so now x minus 2 squared. So if I think about using transformations, the parent function is just our regular quadratic y equals x squared, but it's shifted right 2. So normally vertex on 0, 0, it's shifted right 2, and then it has the usual pattern, up 1 over 1, then up 3 over 1, and then up 5 over 1. Okay. So, but it only, and I can connect and draw my quadratic in here, but it only looks like this when x is greater than or equal to 1. So where I have my kind of dotted vertical line, I am going to connect my points, everything from 1 and greater than, so that's going to be everything to the right, and then I can erase these guys. Okay, and this one is a closed circle because it's greater than or equal to 1. So that point's going to be a closed circle, and then it follows the quadratic path after that. Okay, this one, opposite, we are given the graph trying to write the equation. So we have f of x, we're going to use those big curly brackets. All right, let's start with this one. So parent function of this is x squared, so I'm going to use transformations to try and figure it out. So this guy looks like, let's see, so here's 1. Yeah, these are going by halves, so up 1 over 1. So it has the normal pattern, so there's no vertical stretch, but my vertex has shifted right 3 and down 1. So right 3 and down 1 means I would need to subtract 3 and then subtract 1 outside the parentheses, okay? Now it looks like that, kind of where the break in the action is right here, where it changes from the quadratic to the line, and that happens at x equals 4. So my restriction, it follows the quadratic everywhere to the left, so it's less than 4, and there is a point right here on the end of 4 that's a closed circle, so we are going to do or equal to. This line, okay, we can kind of keep that slope going, so it looks like up 2 over 1, down 2 over 1. So I can imagine this guy continuing down. So it looks like if I were to keep that slope going, and you can use a ruler to help you with this too, it would go through 0. So that means it doesn't have, or its y-intercept is 0, so we don't have to write that. And then the slope, kind of already said it, it's up 1 and over 2, but remember each of these is worth a half, okay? So up 1 and over 2 is also the same as up a half over 1, but that's going to be the same fraction. So it's 1/2 x plus 0, and I don't have to write the plus 0. Okay, and then it looks like this everywhere x is greater than 4. Oh, and it looks like, you guys, that is maybe it for our piecewise functions section. All right, thanks for watching.